Here I have this system of equations. There are three variables, x, y, and z, with three equations. So let's go ahead and attack this one by using substitution, because it looks like this z is going to be easy to solve for, and then I can dump that expression into these two values of z. So let's solve for z right here. Z equals, now this negative 2x is going to be moved to the right as a positive 2x. This positive 6y will move to the right as a negative 6y, and this 10 is already on the right, so he just stays. So we have this expression 2x minus 6y plus 10, and that's going to equal z. So in these first two equations, when I see z, I'm going to put this expression in for z instead, of course using parentheses since I'm making this substitution. So 2x plus 2y plus 3z, but z is going to be this, equals 6. Okay, let's just run through and simplify this really quick. Okay, so my x's are 8x, my y's are negative 16y, and this 30 will be dumped to the right side as a negative 30, so 6 minus 30 is negative 24. And something interesting here, I notice that each of these coefficients and this constant over here, they're all divisible by 8, so I could divide everything by 8 just to make all these values much smaller. So here I would have x minus 2y equals negative 3. So I'm going to kind of put that to the side and come back to this guy in a moment. Okay, so let's go ahead and use this second equation now and substitute our z expression in for z. So negative 4x plus 4y minus 2z, but here's my expression for z, and that equals 4. So real quick, let's just go ahead and simplify this. I'm going to go ahead and distribute that negative 2 through and then combine like terms. Okay, so my x's go together to make a negative 8x. My y's go together to make a positive 16y. And it's a minus 20 equals 4. So let's push this negative 20 over to the right side. So he'll be a positive 20 over there. So 20 and 4 makes 24. Same thing here. I notice that each of these terms is divisible by 8. So let's go ahead and get rid of an 8 there by dividing every single term by 8. So it looks like a negative x plus 2y equals 3. So I have now, instead of a system with 3 equations and 3 unknowns, I now have a system 2 equations with 2 unknowns. Well, something interesting is going to happen here. Let me go ahead and write these 2 equations, one underneath the other. And when I do this, it looks like the equations are identical except one of them has been multiplied by negative 1, it looks like. So when I add these 2 equations, the x's cancel, the y's cancel, but it looks like our constants cancel as well and gives us 0 equals 0. Now recall that when all of our variables cancel and we're left with a true statement, the solution for this is going to be infinite solutions. It's worth noting, however, that infinite solutions doesn't mean that any old ordered pair that I want to plug in will work. It just means that all the solutions have a nice pattern, and there will be an infinite number of ordered pairs that happen to work, but they all must follow a kind of a set pattern. But this system has an infinite number of solutions.